Hello guys, welcome to my channel Sahaj Gyan, where we try to simplify our understanding of knowledge by building our intuition. Today, we will study about a very important topic called gravity. We all have heard of the legendary story of Newton when he was sitting under an apple tree and a question struck. Do you know what was the question? Many of you, like me, thought that the question was, why the apple is falling down? But it seems that the real question that came to Newton's mind is, if the apple is falling down, why the moon is not falling down? And the quest to find an answer to this question led to this beautiful subject of gravity that keeps our universe in such a beautiful balance. Newton's pioneering work of laws of motion was inspired by Galileo's work. Likewise, Newton's work on law of gravity is an extension of the Kepler's laws of planetary motion. While Kepler was more interested in understanding the motion or path of the planets around the sun, Newton was more curious about the underlying reason why the planets move in such a circular path. Kepler's and Newton's work beautifully complemented each other, and we will see the correlation in the next video. From Kepler's work, Newton knew that planets had an elliptical or a circular orbit around the sun. From his work on the laws of motion, Newton knew that there is a force required to keep any object in a circular motion. This force is called centripetal force. Newton concluded that there exists an invisible force between celestial objects like sun and earth that keeps the planet into a circular motion. He called this force as gravitational force. After careful observation and analysis, Newton concluded that force between two objects or two celestial objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Newton expressed the force of gravity between sun and earth as force of gravity is proportional to mass of sun multiplied by mass of earth and inversely proportional to the square of distance between the sun and earth. After careful experimentation, he found that this proportionality can be converted to equality by introducing a constant g, which is also called universal gravitational constant. The value of g is 6.67 into 10 to the power minus 11. So now let's try to find what is the unit of g. If you see here, we can write this equation as g is equal to F times r square divided by mass of sun into mass of earth. So unit of g is, unit of force is Newton, unit of distance is meter square, divided by unit of mass is kilogram, and unit of mass of earth is kilogram. So unit of g is Newton, meter square, kilogram minus 2. Guys, it is just mind-boggling to realize that the force between any two objects, whether celestial or terrestrial, is governed by the same formula. So whether we are talking about force between sun and earth, or we are talking about force between two everyday objects like a book and pen that is kept in your room, the formula is the same. What you need to know is the mass of the object, like mass of the book, mass of the pen, and the distance between the book and the pen, all expressed in SI units. Now you may ask a natural question. If there exists a force between two everyday objects like two books of mass 1 kg kept at a distance of 1 meter, why they are not moving towards each other? Let's try to find out. As per Newton's laws, the force between these two books is equal to g, mass of book is 1 kg, mass of another book is 1 kg, and the distance between the book is 1 meter square, which is equal to g, Newton. Now we know that the value of g is 6.67 into 10 to the power minus 11 Newton. See this power, minus 11. The force is so small that it is not sufficient to overcome the friction between the book and the surface. Let's assume that our everyday objects are kept on a surface, and one of the object is of mass 1 kg, and let's say we want to find the mass of another object so that there is enough force of attraction to overcome friction. We know that the frictional force for a mass of 1 kg is approximately 6 newtons. Now, the force of attraction between these two objects should be greater than 6 newtons, which is equal to G m1 m2 by r square. Let's assume that these two objects are kept 1 meter apart. So if we solve this equation, we get 6 is equal to, let's assume gravitational constant is 6 into 10 to the power 11 minus 11 into mass 1 into mass 2, and r square is 1 square, which is 1. So we get mass 1 into mass 2 is equal to 10 to the power 11 kilograms. From this, we see that the product of masses should be of the order of 10 to the power 11 kg for any significant force of attraction to exist. So it is not surprising that we see the effect of force of attraction between the celestial objects and not everyday terrestrial objects. Now let's try to calculate this force of gravity between two celestial objects, Sun and Earth. If we see, mass of the Sun is 2 into 10 to the power 30 kilograms, mass of the Earth is 6 into 10 to the power 24 kilograms, and the radius or the distance between Sun and Earth is 5 into 10 to the power 32 meter. If we substitute these values into this equation, we'll find that force is approximately equal to 3 into 10 to the power 22 newtons. This is a large number, and that's why we see the impact of force of gravity on the motion of planets. With this, we come to an end of this video. Hope this video gave you an understanding that any two objects in the universe, there exists a force of attraction between them. And this force of attraction is given by this equation G m1, the mass of first object, m2, the mass of second object, divided by r square, where r is the distance between the two objects. We have also discussed that why the force of attraction between everyday object is very tiny, of the order of 10 to the power minus 11 Newton, and you don't see any effect. However, the force of attraction between celestial objects is of the order of 10 to the power 22 Newton, and you see some impact because of that the Earth rotates around the Sun. With this, we come to an end and hope to see you in the next video.